talk about premiums. We're going to start in the fully continuous case. Time for a new random variable, L, which we're going to define as the loss at issue random variable. And the loss at issue is just going to be equal to the present value of the future benefits minus the present value of the future premiums. So as we always do, we're going to start with whole life.
Could you say one more time what all those letters mean?
Present value of future benefits minus the present value of future premiums. More technically, actually, the actuarial present value of future benefits minus the actuarial present value of future premiums, but I just write PVFB for short and PVFP for short. Let's start with fully continuous whole life. Fully continuous means both the premiums are paid continuously and the death benefit is paid at the moment of death. We'll see later where the premiums are paid annually or some other frequency beyond continuously, and the death benefits are paid at the moment of death. So now if we want the loss at issue, we said it's the present value of the future benefit. And when is our benefit paid in whole life? Death, which is what random variable? T. So it's paid at time t, so the present value of that $1 is e to the t. And now if we pay these premiums continuously instead of a single premium, we don't know what that premium is yet, so let's just call it P bar. What's the present value of the premiums that we pay if we pay those as long as we're alive? Continuous annuity for how long? As long as we're alive. Okay. What is A bar angle T?
1 minus
Divided by delta, since this is continuous. So I can rearrange terms and I get this. So now I can use that to take the variance. Actually, let's do the expected value also, and I'm going to do it from here. So what's the expected value of v to the t? Yeah, it's just whole life insurance issued to a life age X. This premium is just some constant that we choose to charge.
Oh.
And what's the expected value of little a bar angle t? It's just a whole life annuity. To calculate the variance, this 1 plus p bar over delta is just a constant. So we're taking the variance of expression as a constant in front. We square that constant. And the variance of v to the t is just the variance of whole life insurance, which was the second moment minus the first moment squared.
Do you need to square that?
First parenthesis should be squared.
Yes. Thank you. Then when we take the variance of that constant p bar over delta, that's just 0. Because obviously if something's constant, there's no variability. Let's draw a pain curve. So now on the y-axis we have our random variable L. If I issue a fully continuous whole life policy and the person dies immediately, what's my pain? A lot. I paid a death benefit of 1, I've collected no premiums. Then, the longer they survive, the less in present value terms that benefit is going to cost me, and even better now, I'm collecting premiums along the way, so the longer they remain alive, the more premiums I collect. So at some point, my loss is actually going to become negative, which is a good thing because a negative loss is a gain.